Okay, so I want to talk a bit about temperature and kinetic particle theory. All right, so let's take a look at the screen. Samuel, put aside the marking for now. Okay, so if you're heating something, right? Example, let's say water. So let's say you're heating up water. So, or any particle for that matter, you will get a curve that looks like this based on the temperature versus time graph. So basically the temperature will increase until it remains constant and then increase again and it remains constant. Can anyone tell me why it will remain constant at these 2 points on the screen? Why do we have a flat line? What do you think? Samuel? The flat line is because
energy is being redirected from heating the substance to breaking the forces of attraction between molecules.
Okay, so that's the explanation. Which we'll go into that later. So the reason why there's a flat line is because there's a state change. So what you're experiencing here is the melting. Oh, wait. Turn this. Yeah, there we go. Okay. Oh, that could work better for you.
Yeah.
This is the melting and this is the boiling. That's why there's a state change. Okay, in terms of energy, can you tell me in which of this, I'm going to label it as A, B, C, D, E. So we have 5 different straight lines. Each of the straight lines indicate that there's a change in KE.
B and D.
No, there will not be a change in KE for B and D. Okay, so ACE will have a change in KE because the temperature increases, or rather the K increases, which causes the temperature to rise.
But the IE changes and B and D.
What is IE?
Internal energy, right?
Internal energy changes at all times because you're constantly taking in heat. So your internal energy must increase. But what you're referring to will be the potential energy. So let's use a different color. The PE here would increase.
Is it called potential energy or internal potential energy?
It's both lah. You can call it internal potential energy if you want. Potential energy is a general name. It could be related to bulk potential energy, which is like example, you raise a ball to a high level. So it has gained gravitational potential energy. So that is known as a bulk potential energy. Bulk referring to consider the particles as one single object. So that's called bulk. Internal energy will be referring to considering the average energy of all the particles inside within the object. So that's called internal energy. So the opposite of internal is bulk. So this heating curve, this is known as heating curve, it's very important. It comes out all the time, and you got to know that the kinetic energy changes when you increase, when you see an increase in temperature. The explanation is later on in the notes. For the state change itself, the potential energy increase because potential energy is related to forces of attraction. So one way of understanding this is, imagine you have a rubber band. So I'm just going to draw a rubber band, and you stretch the rubber band. So when you stretch the rubber band, right, you are causing the rubber band to increase in Potential energy. What type of potential energy is this?
The elastic potential.
Correct. When you release the rubber band, what happens to it?
The kinetic energy.
It will snap back.
Yeah.
Okay, so you have kinetic energy. So imagine you have two particles that are strongly attracted to each other,
Mm-hmm.
and then you pull them apart. So, like a stretched rubber band, they'll be put apart.
Yeah.
Okay?
Mm-hmm.
Now, when you release the energy, they'll go back.
Okay.
So, but when you put them apart, they have increased in potential energy. So that's why you have this increase in potential energy over here. So that's one way of understanding state change. Okay? These are very, very important, and you're looking at 1 or 2 marks questions. So moving forward here, this is the part we explain. Okay? This is a 1 mark question. When heat is applied, the large energy amount of heat is converted to kinetic energy. So we move faster. Average kinetic energy increases, increasing the temperature. So do take note of this. Okay? And we're done for this part. Hope you all have finished the revision. Ishva, you are not here, right? I hope you are watching this video. Please complete this as your homework. Very nice questions here.